Yeah, I think we should start already because it's already 5, huh? And we're gonna do it that way. So basically, the most important part with this problem is first of all to understand how does our relay to operate. If you can be able to understand what is the relay and their contact already, it's gonna be easy for us to move forward to answer this error. Okay. So basically, what happened with the relay, it's basically, if you remember very well on when you go to hospital or any secure place. So there is some door where before they open that gate, they need to press a specific button so that the gates can be activated using the current. Okay. So it's basically the same concept. So we have a coil, and with that coil, if we allow the current to flow in that coil will be excited. Okay? And then by the time that coil is excited, there will be a flux that will be induced. Okay? So we have our coil. If we close that coil gonna induce a flux across it. And then we know that a flux is going to operate like a magnum. So it's going to attract a specific metal to it, or you get a point. So for instance, with the door, when you're coming to a door, you have a lock there. This is our lock. So by the time we close our switch, this will produce flux. And that flux is going to attract this metal to it. So that when it attracts, it's going to open the door, for instance, our gate. Okay? So it's the same operation, but now here we are dealing with what? We have a coil, and this coil has its respective conduct. Can you see? So if I have, for instance, I have my coil R1, and this R1 is gonna have its respective contact, okay? And as you know, this represents a open switch, and then this represents a close, which means initially this one is close. And another way to draw it is we're gonna come here, we say this is a closed switch, okay? And then this one is an open switch, okay? And as we say, this coil, the relay has its respective, how do you call it, respective contact, okay? So that by the time that coil is excited, so if we excite this coil, it's going to close the switch, and it's gonna come here to do what? To open that one. Can you see? The open one will be closed, okay? And the closed one will be what? Open, because it's excited and it's gonna open that one was open, it was closed, and then close the one that was open. You get that concept?
Can you explain it again?
I'm saying, as we say, what we need to do is to excite our relay, which is basically a coil. We excite it, okay? So as for relay one has its respective contact. Its respective, it means, for instance, if I come here, this is gonna be the contact to relay one. And this one is also the contact to relay one. Can you see that? So since this one is initially open, when I excite my relay, what's gonna do is going to close this one. Can you see? When this one is excited, when my relay, the coil is excited, this is gonna be closed, this is gonna be closed. If there was another switch that was open, it was closed initially, it's gonna be open. That's the concept that you need to get that. Is it clear there? Is it clear?
Repeat.
I'm saying our relay is a coil, okay? Is a coil. If we allow the current to flow in that coil, it's gonna be what? Excited, okay? To produce flux, okay? And therefore, if there is a contact that was initially open, okay? That contact is gonna be what? Close. Why close? Because the relay is excited. So if I come with a current, I close here. Can you see that I allow the current to flow? To do what? To excite my relay, my coil. Once this is excited, the initially open become what? Close. Initially open of R1 become close, but each relay has its respective contact. Can you see?
Yeah.
You get a point? So that's how it operates. It means I have a coil. For each coil, it has its respective conductor. So by the notation, when I say R1, if I say contact R1, when my relay R1, the one that was open is going to be closed. The one that was closed is going to be what? Open. If my relay is excited, it's activated. Still on the same page? Okay. So since we understand how does our relay operate, now when it comes to the operation, for instance, for this cutting toe groove, it's the same concept. So we want to make that this control of this cutting groove to be semi-automatic. It means it's going to require you to start it, but the rest of the command is going to be automatic. Doesn't require you anymore to be there fully. Okay. So therefore, for instance, when you take our cylinder A, this cylinder A, we're gonna represent it by this resistor. Okay. If you have this cylinder B, we are going to represent it with this resistor. So a specific voltage must be applied to it in order for it to be activated or to be extended. You get a point? Okay. So when I come here, I don't need even to understand. I just need to identify my relay and its respective contact. So for relay 1, I have R1 here, which is initially open. Here, initially open. Okay. And I come here, I can see that my relay 2, I have a contact R2, initially closed. Can you see that? And then if I come again, I check, I see my R3. R3 has a contact R3 that is initially open, and then R3 initially open. Can you see that? And then we have another relay, which is relay 4. Relay 4 also, it's also initially.
Guys, can we all close our mics?
Can you close our mic, please? Okay. Yeah. So, and as I said, we're gonna have a relay 4 here, and for relay 4, we only have one contact. Can you see? Each relay must have its corresponding contact, and that contact can either be open or closed. Can you see that? So let's start with the analysis and see what's gonna happen now. Okay. So if I come, I press the start button. Remember this button, they don't close when you close. Okay, when you close. So let me draw it easily. Okay, when I close this switch, you close it in the moment. By the time you release your end, it's gonna go back to its initial, okay, position. Same page. So when I press the start button, okay, it's just that I'm gonna allow now the current to flow here, okay, so that my relay is going to be excited, okay. And why did I say once the relay is excited, one of the contactor, those contactor which was open is gonna do what? It's gonna be close, and this is gonna be what? Close. All the R1 become close. Automatically, we're gonna have that. We're gonna see that now we're gonna have a current that will flow to the cylinder A. Can you see that? Okay. But remember, I said what again? I said, if we press here, this is going to go, if we release our end there, it's gonna go what? It's gonna go back to its position of being open, okay? But the good news is that now our relay was excited. Once after being excited, now we have this relay not, it's still closed. So which means there will be a current that will flow in that path. So our relay will be maintained. We're still gonna have a current that's going to activate our relay. Why? Because of this R1, which is in parallel with our start button. And we call this condition, this contactor to be a latch contactor. Each purpose is that when you press the start button, when you release, your relay is still gonna be excited or activated. We understand that part? Okay? So once we see that since our relay is maintained, and then on the second condition, what did they say? Now we press on our S2, okay? So we press on our switch 2, okay? So once you press us on our switch 2, what happened? We are going to excite the relay 2, okay? And then once the relay 2 is excited, what happened? It's going to open its switch. Can you see it? Its contact, which means the R2, which was initially closed, is going to be what? Open now, okay? Which means we have deactivated our relay 1. Can you see that? Okay? Once we press here, this current flow here, this was initially open, closed. Now it's going to be initially what? Open. Automatically on this branch, there won't be any flow of current here. There won't be any flow of current because why? Because once we activated the relay 2, this is going to now become a open switch because relay 2 is activated, okay? And automatically our relay 1 is deactivated. Any question from this part? And then once relay 1 is deactivated, what happened to each contactor? Each contact is going to go back to their initial position. Their initial position is what? Open switch. And their what? Open switch. Because it's deactivated. A question? Is it clear? Any question, please? Is it clear there? Any question?
No, sir, no question.
No question, it's clear. You understand what happened there, huh? Okay? So it means once our relay is excited, all the normally open will be normally closed. All the normally closed will be what? Normal is going to be open. Once the relay is deactivated, the contacts will go back to their initial position. Why? Because this R2, once we press it, the relay R2 was excited and automatically we open the switch R2 here, which was initially closed. Now it's going to be open. Okay, and relay 1, it's going to be deactivated and there won't be any flow of current, which means our cylinder won't have any flow of the current. It won't be excited, which means it's going to return to its initial position. We get the picture? So now, after doing that, now we come again here to relay, to switch 1. Once I press switch 1, what do? I allow the current to flow to go and do what? To excite my relay 3. To excite my coil. And then once the coil is excited, what happened? All the corresponding contact of relay 3, which was open, become what? Close. Can you see? Close. Yeah. And automatically this current will flow in this branch. Okay? And here we're going to have a current that will flow to this cylinder. And then our cylinder B is extended, which means it's going to move. Which movement is that? So it's going to be excited automatically. To the left, huh? Yeah, it's going to move to the left. Can you see that? And then remember, this contactor here, once you press it, if you release your hand, it's going to be open now. Can you see? But the good news is that we have this latch here, this R3, which is still excited, is gonna maintain the flow of the current for our R3, even if we release that switch 1. Okay? But now, to make that our cylinder to return to the right, to move to the right, what do? We come to switch 3. You press it. Look now what happened. The current will flow, okay? And then we're gonna excite what? Relay 4. Once relay 4 it's excited, what happened? The normally close of relay 4 is gonna be what? Open now. Huh? This will be open now. And since that one now it's open, what happened? There won't be any flow of current to the relay. Can you see that? There won't be any flow of current to the relay because now it's become open. Okay? And then once it's open, all the contacts of relay 3, they are going to go back to their initial position, and their initial position is open there and then open there. Therefore, our cylinder 4 won't be excited. Can you see that?
Yes, sir.
So that's how it operates. So now our duty is to answer those errors. You see, A, B, C, D, E, F. They're just error. We need to identify our error. Okay? Okay? Are we on the same page out there? Can we now start to identify? If we understand how it operates, now we can start to identify our error and see what we need to do. Can we start now with solving the problem now?
Yes, sir.
Okay, so if it's clear you understand how it operates, which means it's going to be now easy for us to identify what error is going to happen in our circuit. And then on the first condition, what did they say? They say once you start, you press, okay? You start, the start button stay closed when touch. Can you see? Because we say with this contact, with this switch, they are made in such a way that if you press here, you come with your hand, you press there, it's gonna be closed, okay? But if you release your hand, it's gonna go back to what? To each initial position, okay? But now we are in the case where once you press, you release your hand, but it's still close. It stays close. You get a point? So basically, we are in the case where this start button will remain closed. But the moment we close, even if we release, it's not gonna go back to its initial position. It remains closed.
Guys, close your mic.
Okay? Same page? Same page?
Yes, sir.
Can you see? So next,
No, repeat.
now, what I said is that on question A, they say, by the time you press your switch, okay, this start button, remember they are made in such a way that when you press, if you release it, go back to its position, normally open. Can you see? But now it states that by the time you press, you come, you close it. When you release your hand, it stay closed. It remain closed. It's supposed to go back, but it stays closed, which means it doesn't operate normally. Can you see that? You understand what the problem now? That is error. You press, it didn't go. Once you release your hand, it's still closed. Okay? And now, since it remained closed, what are we going to observe? We're going to see that this current is going to do what? To excite our relay, okay? Okay? By the time our relay is excited, its corresponding contact, which means the contact to relay 1, those one who were open are going to be what? Closed, huh?
Closed.
Those one who were open, closed, they're going to be what? Open, but we don't have that one of them, okay? So we're going to see
Yes,
that
sir.
we're going to have a current that will flow in this loop, and then we're going to have a current that is going to excite our cylinder A. Okay?
Yes, sir.
So let's try to see, because we know that with our normal operation, when we come to press on switch 2, is to do what? To cut the cylinder, because you know that when you press here, the current will flow to excite relay 2. Once relay 2 is excited, what happens? They normally close become what? Open, huh?
Open.
So this normally open, what is the purpose of it? Is to cut the flow of current through the relay. Can you see? So which means once it's open there, automatically here there won't be any flow of current, which means our relay is deexcited, deactivated, okay? And then which means
Yes,
those switch which was closed gonna go back to their initial position, and this one will go to the initial position, which means there won't be any flow of current. Can you see that?
Yes, sir.
But remember now that by the time you release your end, because you press here. If you release your end, what happens? This contact will go back to its initial position, is it? Can you see that? Once you release your end, the switch will go back to its position, initial position, which is to be open. And then relay 2 is not anymore excited, which means this switch there, this contact will go back to be closed. Okay? And then if this contact go back to be closed, what happened? Since this switch, this start bottom still closed, what happened? The current will flow again back. Can you see?
Yes.
The current will flow back, and automatically again, what happened? We close there, we close here, and the cylinder will be again excited. We didn't switch it off. Can you see? You press switch
Yes,
1,
sir.
you switch it off. Once you release your end, it switch on again, automatically. So that's the error that's gonna happen on question A. Because there is no way for us to switch on, to switch off the cylinder A. Once you press, we switch off. Once you press switch 2, you switch off. Once you release, it's go back to, you switch on again your cylinder, because that switch is still closed, which means once you release, the current will flow again. Once you press, the current doesn't flow. Once you release, the current will flow again. So which means that will be the first error that you are going to get in this circuit. Can you write it down? And you understand what is the fault on the question A?
What is what, sir?
The error that we got, the problem that is going up, the failure once that bottom stay closed.
Can you repeat
No.
so that you can write it down?
As we said, we observed that once we press to switch 2 is to excite relay 2. Once relay 2 is excited, is for us to open, because once it's excited, look what happened. I come here, I press with my hand, I close. If I close, I have what? The current that will flow to excite my relay 2. And then once the relay 2 is excited, what happened? They normally close become what? Open, huh?
Okay.
So I'm gonna have an open switch there, which means there won't be any flow of current. Okay? So the relay 2 become what? Deactivated. Once it is deactivated, we say what? Their contact will go back to their initial position. So you can see that we switch off the cylinder A. Okay? Because we have pressed. But once you release your end on that switch 2, what happened? Now, what happened is that once you release here, let me show that our end is here. Once you release your end, this will be open. And if it's open, relay 2 is deactivated, which means this switch for the contact for relay 2, which was normally closed, will go back to be closed. If it go back to be closed, what happened? The current will do what? Will flow again. To do what? To excite relay 1 and then close here and close there, which means the cylinder A will begin again will get power. You get a point? So we won't have any way to switch off our cylinder A. The only way to switch it off is once you press on switch 2, you need to maintain your end. Once you release your end, it's gonna go on again. You press switch 2, it's off. You release, on again. Can you see? So that will be the error in this circuit. Can you see? It's clear now, huh? Can you write it down on your own words, what you understand there? It's clear now there, huh? Any question? Any question?
No, sir.
Yeah, it's clear. So basically, that will be the first error that we observe here. Another error that we're going to observe here is that because of this condition, which means if someone come here by mistake to press switch 1, it's going to operate cylinder 2. But we are trying to avoid the 2 to operate together. So which means we are trying to avoid that when this one is on, this one should be also on. We must operate one, then we operate the other one. But because of this start button to stay closed, if someone come here by error to press switch 1, we're gonna see that relay 3 will be automatically excited, and then this switch will be what? Close, and that will be closed, and then our cylinder B will operate. Can you see? So we have two errors. The first error is that there is no way for us to switch off cylinder A, because once it switch off, it's either when you press, which means you maintain your hand on your switch 2. If you release, it's gonna go on again. You press, it's off. You release it, on. Okay? And if someone come, the second error, if someone come by error to press switch 1, it's gonna make cylinder B to operate, which we are trying to avoid, to have the two to operate together, simultaneous. Can you write it down? Those are the two errors that we're gonna get here.
Can you please repeat them again?
The first error, we say that we cannot switch off our cylinder A, which is we cannot switch the operation of relay 2. Okay? Why? Is because that start button, if it's maintained, stay closed, which means when I come to switch off, I need to press where? To switch 2. If I press, it's gonna go off. But if I release my hand, what happened? The current will fall back again to excite my relay 1. Therefore, this cylinder A will be doing what? Moving up, down, left, up, down. But there is no way to switch it off. Okay? The second error is that if someone come by mistake, once he press to switch 1, we're gonna have the operation of the two cylinders together, which we are trying to avoid, which means there won't be any safety in the operation. Is it clear? So we can move to B. Can we move to B?
Yes,
Can we move
sir.
to B now? Huh?
Yeah.
So we solve
Yes, we
question
can.
A. We solve question A. Now we're gonna try now and solve question B now. Okay. So on question B, they say the normally open of R1. What does that mean? The normally open switch, a contact. We don't call them switch, contact of R1 in line 3. So we have line 3 is here. Okay. And then they said that's normally open, it stays closed, which means no matter what will be the operation of the relay, activated or deactivated, excited or not excited, energized or disenergized, that will remain closed. You get a point there? So
Yes, sir.
when I come here to start my operation, can you see that automatically when I come with my supplier here, can you see? If I come with my supplier here on this branch, can you see that automatically, initially, this cylinder is already operating without me pressing any button? Can you see that? Because it's already closed. Can you see? It was an open switch, now it's closed, which means initially our cylinder is already working. Even if you come, you press your switch, your start button here, you're gonna see that this will go out, will be excited. Even if it's excited, it's gonna do what? It's gonna close R1, but this stay closed because that's why they tell us it's gonna stay closed. There is an error there. Okay?
Yes, sir.
Can you see that? That's the first error that we identify.
Yes.
So the only way to switch off our cylinder A is to remove the supplier on the circuit. Third error, which means initially it's already in operation. In order for us to switch off, we need to remove the supplier on our branch. Third error, which means if someone come by mistake and press S1, automatically what happened? Relay 3 will be excited, and then this switch will be what? Close. If this switch is closed, what? Cylinder A also be what? In operation. We are trying to avoid to have the operation of the two cylinders together. Can we see the error there? So you can write them down, then you can move to questions. C. Any question? Any question?
Can you please
No.
repeat?
Hmm?
Can you please repeat explaining
For
that
question
one?
B.
Question B, yes.
Okay. So for question B, we're gonna start it at the beginning, okay, so that we understand. So which means we're gonna need to have 2 hours. So we're gonna solve. We're gonna go until 1 a.m. I can see that because I need to make sure that we finish it today. As this the problem states here, it say the normally open of R1 in line 3. So we can see that we have line 3. It's here. Say the normally open do what? Stay close. Stay close. Which means it's gonna stay close. Okay? Because remember, the purpose of a relay, once you excite it, the normally open will be closed. The normally closed will be what? Open. But now, it remains closed, no matter what the relay is in which state, excited or activated. Can you see? So by the time we come with a supplier here, 20 volts, you come with a positive on that leg and a negative on that leg. You can see that initially already there is a current that will flow to excite our cylinder. Can you see that? Which means initially already when you come with a supplier, that cylinder is already operating. It's extended initially. Can you see that? That's the first error we
Yes.
understand. Once you apply a supplier, initially it's going to be already extended. So which means even if you have to start the operation here, what will happen is what? Let me just take another color. Once you come, you start the operation here, which means there will be a current that will flow to excite our relay, okay? The normally open will be what? Close, which means there will be another current that will flow there, okay? But this, they won't happen any effect because they say it stays close. Can you see? So which means even if you come to press the start button, already initially, it's already extended. What they use for us to come to start it, initially it's already extended, cylinder A. First error, that's the first error. You understand it?
No, sir, I didn't understand the first error.
That's the first error. We say they normally open R1, okay? In this line, 3,
Line 3.
stays close. If it's closed, what happened? The current will flow, ne?
Yes.
Which means initially the cylinder is already what? Extended.
Yeah.
So which means if I come to up with a source here, 220 volts, which means I connect a leg, positive leg there, a negative leg there. You can see that initially our cylinder is already extended.
Yeah.
There is already a flow of current there. We were supposed to start it, but initially it has already started itself. That's the error there. So they ask us what will happen. And this is what's going to happen in this condition. Okay? And then we said, even if we come to press the start button, the relay R1 will be excited. Okay? The normally open will be what? Will be closed, huh? But this one it's not going to be open because it states here that it's going to stay closed, which means it doesn't depend anymore with the relay because it stays closed. There is an error there. There's a failure of that conductor. And it might happen
Okay.
in the system. It's clear?
Yeah, it's
Yeah.
very clear.
It's very clear. So we
Yeah.
can move to question C.
Yeah.
Okay. So now let's move to question C and see what does it say. It says the normally open of R3 in line 4. Do what? Stay open.
Mhm.
So we go in line 4, and then this will stay open, which means no matter will be the operation of the relay, excited or not excited, there is a failure there. That switch will remain open.
Mm.
Okay?
Yes.
So we start with the operation. We know that every time you have to start the operation, we start with the start button. So you come, you press, there is a current that will flow to excite this relay. Okay? Once this relay is excited, the normally open will do what? Close there, close there. The flow of the current that will go in parallel. Can you see? So if you release your hands on the start button, automatically this will open. But even if it's open, we're still gonna have a flow of current because of what? Of this latch button, which means that contacts in parallel with our start button. Its purpose is to maintain, to assure that our relay remain excited. Okay? So once this is excited, which means here, since it's closed, we're gonna have a current that will flow here. Can you see? Okay? And then when we come to press switch 2, we're gonna activate relay 2. Once relay 2 is activated, what's happened? They normally open, close, they normally close, do what? Open, be open. So here we're gonna have a open switch. If it's open, already we deactivated relay 1. If relay 1 is deactivated, what happened? Here we're gonna have a open switch, and already cylinder 8 off. Good. Okay. We haven't found any error so far. So now we go to the second operation of our cutting groove. Okay. We come now, we press switch 1. We have what? A flow of current. Can you see that? Okay. Which means the normally open will be what? Close. But what did they say about this R3 in line 4? It's gonna be what? Stay open, huh?
Yeah.
Can you see? So therefore, once I release my hand on this switch because I press. Once I release my hand, what's gonna happen? You're gonna have an open switch there. Can you see? It's open. There won't be any flow of current. This one that which was in parallel was supposed to maintain the flow of the current, but it remained open, which means automatically what happened? The cylinder A go what? Off. Can you see the error there? It means R3 supposed to maintain the flow of the current. We're supposed to maintain our relay 3 to be activated, but because it remains open, once I press, I activate my relay 3. Once I release my hands, it deactivates automatically because there is no any maintain there. There is no any switch of maintain. So that will be our error. Is it clear?
Sir. No,
Yeah.
sir.
Hmm?
No, can you please repeat it again? Your last words.
The last word. Huh? So we
Yes.
said we understand
Second.
how this switch operates. If I press, if I release my hand, it's gonna go back to be open. I press, I release, it's open. I press, I release, I press, it's closed. When I release my hand, it's open. Can you see? So when I come, I close here, it's because I press. So which means there will be a current that will flow to do what? To excite my relay. Once the relay is excited, what happens? It's gonna close the open one. It closed this. If there was any close, it's going to be open. Okay?
Open.
But this one R3, the purpose of a contactor in parallel with our switch is to maintain the flow of the current. Okay? but it stays open, which means by the time I come to release my ends, I release my ends, which means this is gonna be open, which means there won't be any flow of current anymore. If there is no any flow of current, which means the relay is deactivated. If the relay is deactivated, which means this was closed, will go back to be open. Can you see? So which means in order for me to excite or to start my cylinder B, I need to maintain my end on switch 1. If I release, it went off. So it become a manual command. It's not anymore semi-automatic. Clear? Clear?
Yes.
Can you see
Yes.
that?
Yeah.
So we can move to how to call it? Question D. Okay. Since this one was clear as well, we're gonna move to question D and see what's gonna happen, because on question D they say the normally open of R3 in line 4. So we still in line 4. And now look what they say. They say stays close. So which means this one it stay close. Okay. Let me just do it right. Stay close. Okay. So now look here. If we come with a supplier, a 20 volt, we put a positive leg there, a negative leg there, which means there will be what? A flow of current in this, and then a flow of current in this. Okay. So the current already, when it's come here, it finds that the switch is open, but this below down is going to do what? It's already closed, which means there will be a flow of current. Can you see? And then the relay will be automatically excited, which means initially our relay R3 is already excited, is already activated. So if it's activated, what's going to happen? R3 here will be what? Will be closed. And automatically this cylinder will operate. Can you see? So initially, the relay R3 is activated, causing our R3, our normally open contact of our normally open of R3 in line 6 to be closed, and therefore our cylinder will operate. So initially we have, that will be the error. Initially already cylinder B is operating because of this R3 which stays closed. Can you see that?
Mm-hmm.
So that's gonna be the first error that we are going to maintain to get in the circuit. First error. Clear?
Yes.
It's clear?
Yeah.
Okay.
No, can you just repeat number D?
Number D. So number T, can you start it again and see? They say the normally open, NO, normally open of R3. So which means we have R relay R3, the normally open of R3 in line 4. Where is line 4? Here. Stays close, which means this one stay close. Can you see that? So if it stays close, which means initially we're gonna have a flow of current, which means we're gonna have a current that will flow from this, from the supplier once the supply is connected in the circuit. Okay. So what's happened to the current? The current come here, it found the switch is open, there won't be enough current, flow of current. But when it's going down, can you see? It found that this is closed. What happened to it? It's gonna flow to excite the relay. Once the relay is excited, what's happened? Because here they say it's gonna stay closed no matter what. We don't follow anymore when the relay is activated or not. So this one, which was normally open, become what? Close. Can you see? So if this one closed, what happened? We're gonna have another flow of current, which means initially our relay R3 is activated initially, causing our normally open of R3 in line 6 to be closed. And then therefore our cylinder B will be initially initially do what? Extended, will be moving to the left. We see that. Can you see that?
Yes.
We can just write it down.
Yes, okay.
Is it written down already?
Yes.
So now let's try and come and switch it off. In order for us to switch it off, what do? We need to press switch 3. Okay? So we want to switch it off. So you come here, I press switch 3. If I press, I made it what? To be closed, which means there will be a flow of current that is going to do what? To excite, to activate relay 4. Once relay 4 is excited, the normally close of R4, which is here, is going to be what? Open, huh? And then if it's open, what do we do? What do we have there? We're going to have a open switch there, which means relay 3 become deactivated. Okay? So if relay 3 become deactivated, what happened? We're going to have again this switch, which was closed, was maintained because it was excited. Now it's going to be open because we have pressed there. Okay? But if we come now, we release our end on switch 3. We release our end, which means there won't be any flow of current. And automatically this go back to what? To be a normally close. And if it go back to be a normally close, we have what? We have another, the current will flow again back to R3. And then R3 will close that. And this will go to excite again that. Second error. Can you see that? Can you see? Everyone has written it down. Huh? You wrote it already down, huh? On your own understanding. Is it clear?
Yeah, it's clear, sir.
Okay. So let's move to question E and F. Huh? It's a bit complex here, but I will try to explain you. Okay. So remember in assignment 1, we were talking about the safety switch. If you remember very well, you wrote something about the safety switch. The purpose of those safety switch is to do what? To block the operation of the 2 cylinder. We don't want when one is in operation, the other one to be in operation. Can you see? Therefore, we have this switch switch 3, which is playing that purpose of safety switch. Okay, so it's a end course, which means basically, let's say we have something that is moving, like your elevator. So you're gonna have a specific switch at the end of each movement. Can you see? If, for instance, this body is moving here, can you see that when it reaches the end, it's gonna do what? It's gonna close the switch, huh? When it move away, it's gonna do what? Open the switch. Can you see that?
Yeah.
So that's how this switch 3 was made. It was made in such a way that when cylinder A it's operating, okay, initially, which means initially from the operation, is it moving up or down? Yeah, now let's say we have initially a switch, okay, which was normally closed because of the movement. Can you please check that? Initially is what? Is it moving up or down? So we
check.
Check it quickly. So we have that body which is already on switch 3, which means initially it's closed. Then for when relay A, when cylinder A is extended, which means it can move up or down or left to right. Let's say left. You can move it in this position. Can you see? So if cylinder A is moving away from the contactor, okay, therefore we move it away, which means it's going to be somewhere there. we move it away. And we can see that, sorry, it's moving away. So which means we're gonna have this block will move away. And then by the time this block move away, we're gonna find out that this switch, it's gonna be what? It's going to be open. Once the cylinder A go back to its initial position, the switch is being what? Closed. Can you see? Okay. So that's why they say when switch 3 failed to open, when cylinder A start moving, can you see? Initially, cylinder A made switch 3 to be closed. Can you see? When it move away, it become open. But look, when cylinder A start moving, this one failed to open, which means it remain closed. Okay? So let's try to understand what happened there in the circuit. Okay? So we say because of cylinder A, initially this is already closed. If this is closed, what happened? The current will flow. Huh? Okay? And automatically this will be what? Open. Huh? Okay? Initially, when we haven't moved our cylinder A. So if someone come, they start the operation, it press the start button. What do we have? We have the current that will flow here to excite relay A. Can you see? Which means once relay A start moving, we close there. And then our cylinder A is going to be extended. When it's extended, which means it's going to move away from switch 3. And then when it's moving away from switch 3, which means we're going to have this going to be now open. And once open there, it will be closed. Can you see? So that's what happened, okay? But the good news is that once this cylinder initially it's not extended, that which means that switch will be closed initially, always, okay? So this one prevent us to do what? If you come here, you press switch 1, can you see? If the current come, it's open there, it cannot flow, can you see? Which means the only way for us to start cylinder B, it's only when you start moving cylinder A. Safety reason. Can you see? Same page? Same page? You understand what's happened there? Can you see? Are we on the same page?
No. No.
I said this switch 3, it's playing the purpose of safety switch. And a safety switch operates in such a way that if you have a block, for instance, block A, okay? If that switch, if this block is already moving away from the switch, can you see? It's open, okay? But if this block move back here, which means it's going to close the switch. Can you see if this one goes back here, it's gonna do what? It's gonna close the switch. Once they close, it's closed the switch, which means this switch is gonna be closed, S3. But initially, our block A is already here on this position. It has closed our switch 3. And once this switch 3 is closed, which means there will be a flow of current, okay, to excite R4, and then R4 is gonna open the contact R4 there, okay? So once that relay R4 there is open, what happened? Which means even if I come to press switch 1, there won't be of any flow of current because cylinder A as didn't start moving. Can you see? It's still on its initial position. It means I must first operate cylinder A in order for me to do the operation of what? Of B. Can you see? A must move first to cut. If A haven't move, B cannot be moving. Okay? But now they say, once A starts moving, cylinder A starts moving, this switch 3 failed to open. So if it failed to open, what does that mean? It means it stay closed. Can you see? It stay closed when cylinder A starts moving away from it, but it's still closed. So which means we're gonna still have relay 4, it's gonna be maintained excited there. And then which means here we're gonna still have an open switch. Okay? So if we finish up with the operation of cylinder A, okay, When you come to B, when you try to press switch 1, it's failing to start cylinder B because there won't be inflow of current. Can you see? So that is the error. The error is such the way that if that switch 3 felt open when cylinder A starts moving, we cannot operate our cylinder B because it's still closed there. The R4 there is still open. There won't be inflow of current. We cannot start our cylinder B. We cannot operate it. We cannot move it to the left. Clear?
Yeah.
Can you see that?
Yeah.
And now they say when switch 3 on on F, when switch 3 failed to close, when cylinder A return, remember we have a block A, which is our cylinder A, okay? When the cylinder move away, this one, it was what? It was open, huh? Okay? But now when cylinder A, it's going back to its position, this one failed to close. It remained open. Can you see that? Which means we're gonna have a open switch on any condition when cylinder A return. Can you see? Which means after extended our cylinder A, after doing the operation of cylinder A, it starts moving. Okay? When we come to start cylinder B, this one failed to open. Okay? So what's gonna happen in this condition? If you analyze what's gonna happen there, because everything is clear. Okay? So which means if this one failed to open, relay 4 won't be activated. Can you see? Let's go back and see. If I come to start the operation of cylinder B, I come and start the operation. The current do what? Flow, huh? Excite my relay 3. My relay 3 is gonna do what? It's gonna close this switch, which means there's gonna be a current that will flow there. And then it's gonna do what? It's gonna close there, which means we're gonna have a cylinder B, which will gonna be start operating. Can you see? By the time I come, I release the switch here. I release my end there, which means I'm still gonna have what? A current gonna flow because of my maintain switch, the purpose of this switch in parallel. Remember what I said already, okay? So when I try to come to press switch 3, it failed to close. It failed to close. It failed to close, which means there is no way for me to switch off cylinder B because there is no way for me to close here. It failed to close. It cannot close. So the operation of cylinder B will remain in the circuit. The only way to switch it off is to what? To remove the supply away from the circuit. Did you write it down?
Still writing.
Yeah.
What number is this, Joe?
F.
Okay.
Is it clear? So which means we have done already question 1. Okay? So with us understanding the operation of question 1, which we are not going to take any long to understand the question 2, because you don't need to be explained how does my circuit operate. What you need is just to see if I come and press on the start button, which is going to be closed. If this one is closed, this cylinder is going to be excited. If the was in excited, this is going to do that. You don't need to be explained. You can explain your circuit yourself just by following each relay with its corresponding contact. Can you see that? So I will explain the operation of this drill system, and now we're going to start finding error. Question 3, you're just going to look under your your, how do you call it, presentation, everything is there. Question 3, everything is just at the end there of your PowerPoint presentation. That's one you can do it yourself. But let's just make sure we finish up with this one. I'm sure it's not going to take us long because now we understand what is a relay. How does it operate? It was a really important part. Okay? Can we move? So I'm not going to read the textbook, but I'm just going to start already explaining because by my circuit, I can analyze and find out what's going on in the circuit. So this is called a semi-automatic comment. It means it just requires you to press and to start an operation. It just requires you to come and press and switch off. Everything is going to be happening itself. Okay? So now what happened now with the circuit? Firstly, we always want to come and press. We need to identify. I have my relay 1. What is the contact of relay 1? We have R1 here, and then we have what? R1 there. Okay? I come here, I have my relay 2. Where is my contact? I have here, and then I have R2 there, and I have R2 where? Here as well. Can you see? And then if I come here, I need to identify R3 as a contact here, and as well a contact there. Okay? And then if I come down here, I'm gonna say that the relay 3, 4 as a contact where? Here, and then as a contact down here. If I come again here down, I'm gonna see that the relay 5 is gonna have a contact up here. Okay? Sorry, from relay 4, I think we jump one contact of relay 4. We have another contact of relay 4 here. So for each contact, I will try to use their color so that you're gonna see what happened for each contact, for each relay. Okay? So now we start with relay 1, which is how to start the operation. If I come, I press here. What happened? The current will flow. Okay? Relay 4, relay 1 is what? Is excited, is activated. Once it's excited, what happened? They normally open become what? Close. Normally open, close. If this one is closed, what happened? There will be a current that will flow down here, which is our maintain switch. Okay? The purpose of this switch in parallel with it is to maintain our switch to be always activated. Okay? And then we can see that there will be another current that will flow here. Therefore, already we're gonna see that cylinder A. Cylinder A is what? Is this part, which means the drill will move down. We're gonna drill. So what happened when I release my hands on the switch? If you release your hands here on the switch, you still gonna have a current that will flow because of that switch, that contactor R1. Can you see that? And now I'm gonna have a look on relay 2. In order for me to activate relay 2, what do I need? I need to come here and press on switch 1. If I press switch 1, there will be a flow of current, which means relay 2 will be excited. Once it's excited, what happens? The normally close become what? Open, huh? The normally open become what? Close. Okay? So if here it's closed, which means up there, if it's open, what's happened? There won't be any flow of current because here the switch not become what? Open. And if it's open there, which means relay 1, it's deactivated, which means their contact here, they're gonna go back to their initial position, and here go back to initial position. So which means the cylinder A will go back to its initial position. Can you see? It was going down for us to drill. Once we press switch 1 is to make it go up. And then we cut the operation of relay of cylinder A. Can you see that? Okay. And now we want to start the operation of cylinder B. And then we haven't finished yet with the contacts of relay 2. We can see that once here it was closed here, what happened? We have a flow of current, which is going to do what? Excite our relay 3. Okay. Once relay 3 is excited, what's happened? You're gonna have a current that will flow here. No, sorry, we jump one step, which means the normally open will become what? Close. Normally open become what? Close. If this become close, what happened? We're gonna have another flow of current here. Okay. And then we're gonna have this here is just gonna be closed. But there is no any flow of current. Okay, because yet open as well. There is no any flow of current. So if I come, I release how do you call it? I release switch 2. Can you see here? If I release switch 2, which means I remove the relay 2 become deactivated. Here it become open as well. But the good news here is what? Now we have that switch of maintain. We're still gonna have the flow of current to excite our relay 3. And now we go down here. We come here, we press switch 2. If I come, I press switch 2, which means what's gonna happen? I'm gonna have a flow of current, which is going to do what? To excite my relay 4. If this one is excited, they normally close become what? Become open here.
Okay.
They normally open. They normally close become open. They normally open become close.
Close.
So by the time here we have an open switch, what happened? We won't have any flow of current, which means relay 3 is deactivated. And automatically this switch, which was closed, become open as well. If it's open, there is no flow of current here. But the good news is that we have a switch of maintain, which means the current will still flow down here. The current will still flow down here to maintain our relay 3 to be relay 4 to become excited. Okay, and then this normally open of relay 4 become what? Close. Therefore, our cylinder B will move to the right. Same page, eh?
Yes.
So now, if you want to come and switch off cylinder B, we come, we press switch 3. Switch 3 will do what? Will make a current flow to excite relay 5. Normally open, close of relay 5 become what? Open, eh? If it's open, what do we have now? We're gonna have a no flow of current here, okay? Which means if there is no flow of current here, this was closed will be open, this was closed will be open already. Our drill will move to the back, to the left. That's how this operates.
To the left, sir, not to the right.
To the left, yeah, to the left. That's how this operates. Once you understand the operation, now you can start doing your fault finding. Same page? We're still on the same page, huh?
Yes,
You understand
sir.
the operation of this drill?
Yeah.
Okay, so now let's start with our fault finding and see what may be the problem when anything happen in the circuit. So you should be an engineer which has that ability to analyze the circuit without being explained. Yourself can see that if I press here, this will happen, this will happen, this will happen, this will happen. If I press here, this will happen, this will happen. Automatically yourself, you explain yourself your circuit. So if you understand how this operates, to find the faults become easy. Okay, so we're gonna move and look at question A. Under this question, they say, if switch 1 fail to close, what is switch 1 here? Okay, what was the purpose of switch 1 in our circuit? It is to do what? To switch off cylinder A, huh? Can you see? The purpose of switch 1 is to switch off cylinder A to make it to move up, because cylinder A is gonna be moving down. If you press switch 1, this will move it what? Up. But now this switch fell to close. Okay? So let's come at the beginning and see what happened. I come, I press my start button. The current flow. I excite my cylinder, my relay 1. Normally open become what? Close. Normally open become close. Here we have a current that will flow here. And then when I have a current that will flow to do what? to excite our cylinder, which means it's going to move where? Down, huh? Okay? So if I release my ends on the switch, but I'm still gonna have a current that's gonna flow because of that contact that was maintained in parallel feet. Can you see? But when I come on switch 1, I try to press it, it fell to close. Can you see? When it fell to close, what happened? This won't be activated. If it's not activated, which means this switch will maintain to be closed. So which means there is no way for us to switch off, because we know that if you press here, this will be excited, normally open, close will be what? Normally open, normally open will be what? Normally close. But this condition has failed because there is no way for us to close it. It failed to close. Can you see? So which means the error here, because it failed to open, we cannot deactivate, we cannot, how to call it, can you explain it? We cannot make our cylinder A return to its initial position. Can you see? Because this one failed to close, the purpose of this one to be closed is to excite this relay 2 so that this will be open. Once this is open, what will happen? There won't be any flow of what? Flow of current to excite our relay 3, our relay 1. And automatically this will be open so that relay A won't be excited and it's gonna move up. But now the problem is that this switch failed to be closed, and then it failed to be closed, which means relay 2 won't be excited. Okay, relay 2 won't be excited, causing our cylinder A to not move to the up, to not return to its initial position. That's the error. Did you write it down? Did you write it down? That's the error that we
Yeah.
found there.
Can you please repeat the last part?
As we said, because switch 1 failed to close, this will cause our relay 2 to not be activated. And if our relay 2 is not activated, this is going to cause our cylinder A to not return to its initial position. So my English is long, but you have understand already what happened. So you can use your own English just to make it simple and short.
Yes.
Clear?
Yeah.
So let's move to B and see what's going to happen. On B, it was stated that this switch 1, the same switch, now failed to open after it was what? It was closed. Can you see? So if I come here, I start my operation again. I start my operation. This is excited. Once it's excited, normally open become close. It's gonna make a current flow in this direction. Normally open become close, which means our drill will move down. Okay. And then once I release my end on the switch here, this will open, but the good news is that the current will still flowing to maintain my switch and my relay activated. But now the problem is that now they say switch 1 failed to open after it was closed. What does that mean? I come here. When I press switch 1, it's closed. Ne? Once it's closed, it's what? It make the relay 2 to be what? Excited. Huh? If it's excited, which means this was normally closed, become what? Normally open. Huh? If it's there, we have a open switch. If there we have a open switch, what do we have now? We're gonna have a open, the one spinning flow of current. If there is no any flow of current, relay 1 is deactivated. This one, it's open switch because, and here it's open switch. which means the drill can go up. Can you see? But now we are in the condition where after we press, even when you release your hand on switch 1, it remains closed. It's failed to open, because remember, if you press, it's closed. If you release what? It's gonna open, but it failed to open. What can be a problem now if this one failed to open? Try to see. Someone can give me an answer to this, please. This one failed to open, it remains closed. What will happen when we come to start the operation of cylinder A? Someone can give me an answer to this. It's straightforward. What will happen? It's straightforward.
I think R2 will remain activated.
Activated, which means
Yes.
the normally close will remain what? Open. The
Yeah.
normally open will remain what?
Close.
Will remain
Closed.
closed. So let's say now I come, I want to do the operation of, I want to drill something. You come, you press the start button. What's happened? Is there a flow of current? There is no,
No.
because this one remain what? Open.
Open.
That's the error. That's the fault. Which means we cannot restart our operation. We cannot restart the operation of cylinder A. Why? Because the cylinder A remain activated, causing our system, which means we cannot restart. There is no way for us to restart again to come and switch on our cylinder A, because there it's gonna stay open like this until we come to remove the supplier. Clear?
Yes.
So we can move to C. Clear?
Yes.
Yeah, so let's move to C. You can see that already everything become clear. Okay? So now we're gonna move to C and see what does C say. It says the normally open of R2 in line 4. What is our line 4? It's here.
Yeah.
So they say the normally open of R2, this one, stays open. Stays open. That's the fault that we have there. So as an engineer, we need to start at the beginning of our operation of this drill and see what's gonna happen. So if I come at the beginning, I start my operation, the current flow. The relay is what? Excited.
Yes.
And once this relay is excited, what do we have? The normally open become what? Close. Normally open, close. Here we have a flow of current there. Once I release my hands on the start button, what do I have? I'm gonna have a switch that's gonna remove there. There's not be that's gonna be open, but the good news is that this maintain switch is gonna make the current, gonna maintain my relay to be excited, and therefore my cylinder A is gonna be excited, or it's gonna move down. It's gonna be extended. So by the time I come, I press switch 1. Okay, I would have relay 2 that's going to be excited. Let's use another current. And then if it's activated, this will be what? Normally close become what? Open.
Okay.
Normally open become what? Close. But remember, they say this one do what? Stays open. Which means even if the relay is activated or not, this one remain open. Okay? So once you go up here, you're gonna see that because this one is open here, what do you have? You have this one, they won't be in flow of current again. Relay 1, go back to its initial position. This one's gonna be open, which means cylinder A will go up, and here is gonna be open. And then if you release your hand on switch 1, what happened? Cylinder 2, relay 2 become deactivated. The switch go back to its initial position. Okay? So let's say now you want to start the operation of cylinder 2. Remember, this one still what? Open. So you come here and say, let me try and start the operation. You press on switch 2. And then you see that here it remain what? It's open there. Huh? Yet what? It's open. There is no way to start the operation of cylinder B. Can you see? That's our fault.
Mm.
Is it? If that one stay open, there is no way to start the operation of cylinder B. No way. Because the purpose of the switch, it was when it's closed, okay? It's going to do what? To excite relay 3. Once relay 3 is excited, this become what? Close. And then this is going to be what? Okay? And then this will become what? Close. When this is closed, then we're going to have what? A flow of current when we come to press switch 2. Then we're going to have a flow of current to excite R4. But because we don't have any, this one will stay open. This operation, there is no way because it's going to remain open like this. Can you see? Can you see that? So we can write it down. Can you write it down? Did you write it down?
Yes.
No.
Okay, I'm just going to give you a few minutes. So we just remain with 3 questions and then we'll be done. Can we move? Can we move? Can we move to question D? We can finish it. I think in 10 minutes or 15 we'll be done. Can we move?
Yes, sir.
Yeah. So now we're gonna try to solve question D again. Again, we are engineer. It's all about to analyze. You understand how this work, and then to solve a problem, it's like this. So basically, even if you go under a company, you should have this ability to you understand the operation of something, and then you can solve the problem when something happens. So that the purpose of this power electronics 3 or power electronics 4, those control systems is just to push you to think, to have a problem solving mind of set. Can you see? So question D, it says normally open R2 in line 4 stays closed. Line 4 normally open of R2 stays what? Close, huh? And again, we need to start at the beginning. In the beginning, like in the Bible. You start from the beginning and then you understand what will happen to the end.
Mhm.
Okay? So now we come here. One thing we observe is that in the beginning, when you have this 220 volts, yeah, sorry, it reminded me of Jacob Zuma. So if if we come from the beginning, then you're gonna have that if you apply a voltage, you're gonna have this voltage that will be applied from the supplier. Okay? So if this voltage is applied from the supplier, initially you're gonna find out there will be a flow of current here already. Okay? This flow of current is gonna do what? It's gonna maintain. It's gonna maintain what? It's gonna maintain our. It's gonna activate our R3. Can you see? Which means initially our R3 is activated. Once this is activated, what's happened? The normally open become what? Close. Normally open become what? Close. Which means you're gonna have another loop there of current. Initially. Please write this one down. Initially, relay 3 will be activated, causing the normally the normally open of R3 in line 4 to be closed, and the normally of R3 in line 5 to be closed initially already.
Yeah. Can you please repeat?
I said initially relay 3 will be activated, causing the normally of R3 in line 4 to be closed, and the normally open of R3 in line 5 to be closed initially. Did you write it down? Did you write it down? Huh?
Yes.
Okay. So let's now move. Initially, we found that we have already one fault initially. Then we're going to try to have a look now and start our operation of this drill. Okay. And then we're going to see what's going to happen when initially this condition is already happening. Okay. And then one thing we observe is that if I come initially to start the operation, I press here. So what's going to happen is that we're going to have this, going to excite what? Our relay. Let me just make a different color for this operation so that you can understand. We're going to make a comparison. Initially is in blue, but when we come now, we press start button. What we see is that this is going to be activated. Once it's activated, the normally open become what? Close. And then the normally open become what? Close. And therefore, this when I have a flow of current that will go down here, okay? If you release your hand on the start button, automatically you see that this will be open, but we're gonna still have a current that will be flowing to maintain that relay 1 to be activated. And we're gonna have another current that will flow here to do what? To make our cylinder A to go down. Can we see? So let's say now someone wouldn't know, come by mistake to press switch 2 and see what's gonna happen in the circuit. If someone come here and press switch 2, what happened? Because this R3 is what? Is closed, huh? The currents do what? The current will flow. If the current flow, what? R4 is what? Activated. If it's activated, the normally open become what? Close, huh? The normally open become what? Close. Which means when I have the two cylinder will go in operation together. Can you see that here you have this, there is a here and this. What's gonna happen? It's gonna be a kaboom there. Can you see that? So while cylinder A is in operation, cylinder 4B is gonna be also in operation. Can you see that is a we don't have any safety. This is a hazard. Like Mr. Jubek was telling you about the safety. This is all about safety. We cannot have the two drills to be operating together because they're going to collapse. So you can try to write it in your own English. Did you write it down in your own English there? To see the mistake? Which means if someone come here by mistake and press switch 2, there is no any safety switch. There is no any safety here because we're supposed to have a log. When we mean by the log, it means when one is in operation, the other one should not be in operation. Even if someone come to press by mistake, it should not be in the operation. And those switch, we'll call them. So what you're gonna say is that R2 in line 4 the purpose of the normally open, okay, of R2 in line 4 and the normally open of R3 in line 5. The two are safety switch. Their purpose is to make sure that when cylinder A is in operation, B should not never be in operation. When B is in operation, A should never be in operation because we are trying to avoid a collapse. And in physics, when two bodies have the same material, what happens? You have, how do you call it? You're gonna have heat that will be formed. If you take your hand, you are moving together already, you're gonna feel that it's getting hot. So there's gonna be a collapse there, and we are trying to avoid that. Can we move to question E? Question E. So I'm just gonna do question E, but I will let you to go through question F yourself because I cannot give everything. At least we have done everything, which means no, at least let's say question E and F. I give you a challenge. Tomorrow, if you want consultation, you're gonna ask me a question about it. Try to solve question E and F and then give me a feedback. My phone number is, I'm the admin in the group there. Is it okay? And I will upload it. I will upload this video on my YouTube channel. Once it will be available, I will send you the link in the group so that you can watch it again anytime. But question E and F, I give you a challenge for you to go through it yourself. Okay? So thank you so much.
Yeah.
Thank you so much. It was a good session. I hope everything went well.
Thank
That's basically
Thank you so
what's happening.
much.
Okay, Ash.
thank
Sure.
Yeah.
So have a good night. Have a good night, guys. I will upload it anytime soon. Huh? Sure. Thanks. Huh?
Moro.
thank you.
Sure.
Thank you.